Okay, now we're looking at number 7 here on this test. It says the formula above gives a monthly payment, M, needed to pay off a loan of P dollars at R% annual interest over N months. Which of the following gives P in terms of M, R, and N? So we have monthly payment, and it's denoted by M, same thing for P in dollars, same thing for R, percent annual interest, and N is months. So the question is asking, rearrange this big equation in terms of P. I don't care what number P is. I don't care what number M, R, N is. I just want to rearrange this huge equation and just have it P equals something. Let's look at our answer choices. So that being said, if I really wanted to, I could do some pretty complicated math here. Take some exponentials, take some logarithms, get rid of this exponent on both sides. But since honestly I don't care what value R ends up being, N ends up being, or M or P, here's what I'm going to do. I'm going to substitute this whole top part and I'm just going to call it A. Same thing for this bottom part. Instead of having this huge bottom denominator, I'm going to substitute all this part and just call it B. Therefore, when I rewrite everything I have, I'll have M equals everything on this top part, but instead of writing this whole thing, I'm just going to rewrite and say it's A. Ooh, apologize. A over this whole denominator, which instead of writing 1 plus R over 1200 to the n power minus 1, I'm just going to write B and multiply it by P. And so now I could just solve this equation for P. So let me rewrite this to put my P on top and just isolate P, get P by itself. So multiply both sides by B, and I'll go to right here. We'll have BM equals AP, and then to isolate P, you divide both sides by A, and P will end up being B times M over A. Okay, so our answer choice must have this huge part of our fraction, 1 plus R over 1200 to the n minus 1, that must now be in our denominator. So looking at our answer choices, okay, looks like B might work, but our answer choice must also have this part in our original numerator that must now be in our denominator, and that works. And M must be on top or be multiplied on the side, and that works there. So looks like our answer choice would be B. Again, you could have done all this complicated algebra and manipulating your variables and moving stuff around, but I actually really don't care what the value of M is, R, N, P, or B, or N, or any of those things, since I just want to give P in terms of M, R, and N. I just now substituted this whole denominator in terms of, and just said it was A, and this whole denominator in terms of B, my whole numerator in terms of A, my whole denominator in terms of B, and just solve for P in this case. Now we're looking at number 8 on this test. So if A over B equals 2, what is the value of 4B over A? So the biggest thing about this test, sometimes you'll get questions like this, where it seems kind of intuitive to just plug in a value for B and a value for A, and we get just some random value. You'll see these type of questions very often, but what they want you to do is, knowing this information, A over B, that equals 2. How about this? Let me just rewrite this now. Instead of saying A over B equals 2, let me just say A equals 2B. All I did was just multiply both sides here by B, and so that got rid of the B in the denominator and just end up moving the B to the other side. What this does for us now, using this 4B over A, I'll write 4B over, well, instead of writing A, I'll just write 2B. Since we now have a common variable in my numerator and my denominator, those cancel. we get 4 over 2, and that can be reduced to just 2. And so now your answer would be C. This can work as well if I did, instead of solving for A here, what if I just solve for B? So in this case, if I was to work it out, I can say that B equals 2A. Actually, A over 2, I apologize. B would be A over 2. Now, this one may not be as intuitive to see, however, both ways work. So same thing like I did in this other one. I solved for A, and I plugged in A to my denominator. Same thing here. I have 4 with my B on top, so instead of writing B, I will now write A over 2, and then just keep my A on the bottom. Alright, so here, let's combine these things here. 4 times A over 2, well, this cancels here, and this reduces to 2. Therefore, we'll have 2A over A, and then that will end up giving us 2. So, notice you can do several different methods here. This one I would probably prefer because it's a lot quicker. This one may freak some people out a bit. However, you both end up with the answer of 2. And then, so that means the answer to number 8 would be C. Now let's look at number 9 on the same test. We have these two equations here. Whenever you have more than one equation stacked on top of each other, that is called a system of equations. In this case, these are a system of linear equations. So we have 3x plus 4y equals negative 23, and then 2y minus x equals negative 19. So what's the solution? Solution being xy to the system of equations above. Question is just asking us, I want to find some certain value for x and some value for y, so that when I plug into this top equation, I get negative 23, and when I plug in that same point into this bottom equation, I get negative 19. And just here to the side, I just rewrote it here, and I just switched my bottom equation. So, system linear equations, there are several different ways to solve these. If I had a calculator, what I could have done is solve both these equations and just put them into y equals. And since they both would have been in y equals, I could have graphed them on my calculator and saw the point where they intersect. That would have gave us the same xy that works for this top equation and this bottom one. That being said, this is the no calculator section. So we'll use two common methods. You normally will see them called substitution and elimination. I'll go ahead and do them both. In this problem, I would probably prefer elimination. Either way, you can do whatever method you prefer first. That being said, let's work this out here. Elimination. The whole point is to eliminate a variable. So you can either eliminate your x or eliminate your y. That's why I changed this original equation to match up my x's and match up my y's. So in this case, I can, let's just go ahead and eliminate our x's here. So how can I eliminate my x's? What I need to do is do 3x plus something. I want to quote unquote eliminate it. Basically, add them together, that equals 0. So 3x plus something equals 0. Obviously, 3x minus 3x equals 0. Let me multiply everything in this bottom equation by 3. And I'm just doing a dashed line here so to keep it separate. I'll just rewrite my first equation. And now, since I'm multiplying everything in this bottom equation by 3, I'm going to distribute this 3 to every single term within this second equation. So we have 3 times negative x, that is negative 3x. 3 times 2y, that's 6y. And negative 19 times 3, that would be negative 57. So, like I said, whole point was to eliminate a variable. I just chose to eliminate x. I could have chosen to eliminate y. Same thing. If I wanted to eliminate y, I would have done 4y plus something equals 0. It would have been 4y plus negative 4y. I would have to get this 2y to be negative 4y, so I would multiply this whole bottom equation by negative 2. Well, let's continue with this here. Let's add these two equations. So 3x plus negative 3x, that is 0x. I won't write anything there. 4y plus 6y, that is 10y. And then we have negative 23 plus negative 57, that would give us negative 80. And now we can solve for y. Let's just divide everything by 10. And we'll have y equals negative 8. What does that tell us? That tells us for a certain x value, I'm not sure what that is yet, whenever I have y equals negative 8, I have a certain x value that works for both equations. What that means is I can now plug this y equals negative 8 into either one of these two equations. Obviously, you probably prefer the easier of the two equations. In this case, doesn't really matter. I'll go and plug it into the 2y minus x part. So I'll do it here. So 2y minus x equals negative 19. But instead of saying 2y, I'll say 2 times negative 8 minus x now equals negative 19. Okay, so that's negative 16 minus x equals negative 19. And we'll get what? Negative x equals negative 3. And now give us that x now equals positive 3. So, system of linear equations. We have y equals negative 8 and x equals 3, which would give us an answer of B. So, there could have been, I could have, if I wanted to, plug in y equals negative 8 into the top equation, and that would have given me an answer of negative 23. Actually, let's do that right now. So let's plug in y equals negative 8 into our top equation. We saw it worked for our bottom equation, but let's say you chose the top one. I will argue that it works with either equation. So instead of writing y, I will write negative 8. So 4 times negative 8, that gives us a value of negative 32. And that equals negative 23. Add 32 to both sides. 3x will now equal 9, which will give us a value of x equals 3. So you can solve whichever way you want to do, either x equals 3 or x equals 3, we still get a value of x equals 3 and y equals negative 8. Answer choice of B.